This is the, I want to say, 15th take where I've started recording and been interrupted rudely, brusquely. Or is it brusquely? Brusquely. Probably brusquely. It's like a rude broccoli. Brusquely. But I'm recording a video today. I was going to just write a blog post, but I was not so rudely interrupted by this lovely drink called the Monte Carlo, which is 2.5 ounces of bourbon, about an ounce of Benedictine, and just about whatever kind of bitters you have sitting around the house. You could do Angostura, cherry, just about anything you might have, and it's a very nice cocktail. It's stiff. It's a stiff one, and it killed my motivation to write, but it did make me a bit talkative. So we're going to chat today. We're going to have a little chit-chat, a sitting chit-chat. It's probably the best idea, about residual predicates and different ways that you can fix them or make them faster, I guess. Figure out if they're a problem. It's probably a good thing, right? You can figure out if there's an issue with this residual predicate. Figure it out. So we've got this index, because where would we be without an index? Be nowhere without an index. We've got this index on the post table, in the Stack Overflow database, on the post type ID. Ooh, I highlighted too much. Post type ID, score, and owner user ID columns. And we have this index because it is fantastic for this query right here. Because this query has a where clause on post type ID and score, and a join clause on owner user ID. Now, in the grand scheme of things, this is a fairly good indexing strategy, because we have our key columns up front that help us with the where clause, that help the where clause find data, but we still have our join clause column in the key of the index. So that's a pretty good starting place. Like if you need to design an index, you're like, I need to help this query. Where this query has to find data, has to join data, has to do all sorts of stuff. And that's a pretty good way to design an index. Help it find all the data that it needs, and then help it join whatever data it needs. That's a pretty good strategy there. And the thing is, when we put that data into a temp table, right? Let's actually run that and do it, because I want to show you just how fantastically fast this query runs because of this professional grade index. It finishes, my friends, in 12 milliseconds. 12 milliseconds. Fantastic. Who's the best query tuner? The problem is, or the problem becomes, that when we need to use that temp table to derive some additional information from our database, we have some figuring out to do. We have a query that just does not run as fast as we would like it to. So we'll hit F5 here, and we'll wait patiently for around about 7 seconds for this thing to churn its wheels and do whatever it is it needs to do to send us data back. Okay, 6.6 seconds. Fine. I said about 7. I didn't say exactly 7. I don't get on my case, Buster. There is our 6.6 seconds of time. And what happens in the query plan really isn't all that important. It's just not that important. I mean, we can see that we have another semi-disastrous repartition stream. Or, I'm sorry. That's over here. We have this repartition streams over here that I don't like. But this query takes about 7 seconds. And if we look at the index seek over here, something kind of interesting shows up. We are able to seek to the post type ID that we care about, right? 1 and 2. That's good. That's fine. We come over here and we join to that owner user ID column, and that's probably fine too. I'm not going to complain too much about that, but I am going to complain about the fact that this takes 7 seconds, and that's about, I don't know, depending on how good of a query tuner you are, somewhere between 4 and 6 seconds too slow. Now, normally, something that I enjoy getting to do in my life and my query tuning work with people is taking a subquery like that, a scalar subquery in the select clause, and replacing it with an outer apply. Now we have to use outer apply here. If we use cross apply, we will restrict results. One thing that this scalar subquery does, despite the fact that it has a where clause with an and in it, so it's extra where clausey. But one thing that might happen is we might not have a result from that subquery show up, but that wouldn't restrict rows. This would restrict rows if we used cross apply, but if we use outer apply, something terrible will happen. My normal query tuning trickery will not work. Now, if you've read my blog, you may be familiar with how much I hate eager index spools. Now, you can't see how terrible it is here, but if we go look at a query plan that I have saved off, professionally saved off for you, we can see that we have a query that will spend 8 seconds scanning the post table and then 1 minute and 20 seconds building an index for us. If you want to know more about that, you can read all my other posts about eager index spools. But what's extra funny about this particular eager index spool, or really about every eager index spool, is that even if we got it to go in parallel, it would not run faster. It actually runs a few seconds slower. Look at that, 1 minute and 31 seconds. And that is because, of course, the eager index spool is a dirty, filthy liar. And I'm going to say off the cuff, that's 46 million rows, and they all end up on one single solitary thread. So getting this query to go parallel does not provide any benefit for us whatsoever. Lovely, isn't that? Lovely. Now, we could try doing all sorts of stuff with top 1 to get rid of the max, but unfortunately, if we do that, both of those plans are going to end up doing the same gosh darn thing with these eager index spools. Have mercy. Have mercy on all of us. So, this is about where I started feeling personally aggrieved, because I felt in my professional query tuning opinion that there is no way that my lovely outer apply trick should be slower, should result in an index spool. All right. So what I did was I rather than go with the maxing, I want to do the top 1 thing, but I also wanted to try separating things out a little bit, doing things a little bit differently. And so I'm going to run this select from my temp table with just the results of post type ID 1. Remember, up here, we're looking for post type ID 1 or 2. That's a question or an answer right there. And if we run this is remarkably fast. Despite having a very lazy spool over here, it is remarkably fast. This is not our problem. We can kind of get a feel for this, because if we look at the index seek over here, right? We don't even have to really get the properties. We can just get the tooltip. But you can see that we read 472,310 rows, right? It's not too bad. It's maybe a lot of rows, kind of. But this is a very fast query. Very fast, 233 milliseconds. Nearly broke the sound barrier. Definitely broke a track record. You show me someone with a 233 second mile. Oh, love to meet that person. That person is a spaceship. Space jokes. Hate myself. But if we try that again with the post type ID equals 2 portion of the query, this will be incredibly slow. And it's so slow, in fact, that I refuse to run this query and make you watch it run, because even though it has the exact same query plan shape, the time is not what it once was. This takes a full 2 minutes and 1 second, which is actually somehow a little bit worse than that eager index spool plan. Somehow, we found a way to be worse than an eager index spool. Now, if we look at the index seek over here, we read quite a few more rows. I don't know what this number is. It is a 339754549. That is a 10-digit number of rows that we end up reading, that we end up seeking to, because you know how seeks are always so much faster. I kind of wish we had just scanned this thing, because the seek is not working out for us here. So despite all we've done to set up our query and our indexes to provide a nice seek, we do not get a very timely seek, do we? It is 2 minutes of seeking. Now, what's kind of interesting is we seek to this post type ID, and then we have this residual predicate on owner user ID. This is where the problem really is. Just because we can seek to post type ID equals 2, that doesn't really buy us a whole lot. There are a lot of post type IDs of 2 in the post table. There are many of them. There are lots of answers in the post table. And the fact that we can seek to every single one of them is great, but then we can't just immediately seek to the owner user ID that we care about. Because we have that score column in the middle, remember? Because we're using that index over here, that east index. And our index, of course, because it looks like this, we can seek to here, but then we have this sort of thing right here in between what we need to seek to next. We have this score column sitting between us. And this goes back to a lot of stuff that I've said and talked about and written about with indexes, where when you create these row store indexes, the order of key columns matters quite a bit, because we introduce dependencies going from right to left, right? So like we can seek to post type ID and we can seek to score, but even if we seek to post type ID, we can't seek to owner user ID after that. We have to go through score somehow to get to owner user ID. So we kind of get a bit stuck, don't we? We're stuck not being able to get through score. And of course, this having score second actually works out pretty well for us generally, because when we seek to this post type ID, we have score in order for the order by here. So having score in the index there is actually a good idea. I mean, not only for this part of the query, but that first query that populated the temp table, that was a good idea there too. That helped that query finish very quickly. So one thing we could do if we were feeling particularly ambitious is we could use outer apply twice. In the first outer apply, we can get the top one score for what we know is fast, right? Post type ID 1 is fast. This finishes in 233 milliseconds. God bless. And we can use the score that we pull out of here as an additional predicate in the second apply. And what this does is it helps us bridge that gap between post type ID and owner user ID. We're going to use score as another predicate. So we're going to be able to use the full extent of our key columns. If we run the query like this will also finish very quickly. In fact, 290 milliseconds is still breaking some records. So that is absolutely lovely. But keep in mind, we have see the optimizer is telling us we could do better. We could create an index and do better. Yeah. Thanks index. Thanks. You're wrong, but that's okay. It's okay. You're allowed to be wrong, optimizer. That's why I'm here. So whenever I explain that to people, though, they get very confused, right? Because if you look at the query plan, right, you have this one seek up here that does the residual predicate thing and is on owner user ID, and it's fast. It doesn't matter because it does a very small number of reads, 473, 2,310 reads. And then when we come and look at the index seek down here, it looks a little funny, doesn't it? So in this one, we look for that post type ID equals 2 first, and then we have another seek predicate now, where score is greater than expression 10003. And that's just lovely. We have another seek predicate, and that other seek predicate helps us have another thing to help us find our data faster. That expression 1003 is what comes from here, right? So getting the score from this part is expression 1003. And one way to kind of make it a little bit easier to visualize what's going on in your head is to take the result of that first apply operation, right? So where we get post type ID equals 1, and dump that into a temp table, right? And that happens very quickly. In 57 this goes parallel and takes 57 milliseconds now. Whew. I'm gonna have to fan myself. I'm gonna have to give myself a spritz, take a cold shower. But now, well, this too isn't slow. My comment is a liar. But now if we select from that second temp table and we outer apply the portion to get post type ID equals 2, what we're going to do is take the score that's in our temp table and use that as a predicate. So before we took the one from the first outer apply and use it as a predicate in the second outer apply. But a slightly easier way to visualize that is to do something like this. And if we run this query, this will also be lightning fast. This is 58 milliseconds. That further breaks our track record, because now we're down to like 100 and something milliseconds between the insert into the temp table and that. So that's actually maybe the better strategy. Maybe. I don't know. I might be crazy. Maybe we should take this first outer apply and put it into our initial temp table select, and then get the second one after that. And we would only use one temp table instead of two, which is be wonderful and lovely, but who knows? Who knows? Now, the whole reason why this works is because of the order of the key columns in our index. Again, post type ID and then score sort of set this thing that we can't get past, right? Because the ordering of the index depends on the ordering of our key column. So it's ordered by post type ID, and then within duplicates of post type ID, we have score in order, and then within the duplicates of score, we have owner user ID in order. So it's that dependency going from left to right or right to left in the row store indexes that it really kind of beat this query up, because we couldn't seek to post type ID and then seek to owner user ID. We couldn't just like hop, skip, and jump over score to get there, could we? Now, we could try shuffling the order of the key columns, right? We could go post type ID, owner user ID, then score, but you can't always change indexes. It's not always easy. That index might be there for a bunch of other queries too. If we change this index, it's going to mess up a whole bunch of other queries potentially, isn't it? It's going to mess a whole bunch of downstream stuff up. Maybe other queries doing things. So we don't know. We don't know what might happen. We don't know. We could add another index, but then we have two indexes that have nearly the same data in them. And that's... it's depressing, isn't it? Why would we ever want that? Duplicative indexes. Another thing that we could do is get our max score a slightly different way by using something like row number. So we could get row number from posts for that, and then do our filtering after we get the row number. But boy, oh boy, in row mode, this sucks. In row mode, this is just as slow as the first query we ran. It took 7 seconds. It's not breaking any... Well, I suppose that actually is breaking track record still, isn't it? No one has a 7-second mile. But yeah, this one takes much closer to 300 milliseconds closer to 7 seconds than the original query, which took 6.6 seconds. But if we get some batch mode involved, now I have this table called T. I mean, fine. I'm not the most creative person in the world. I have this table called T in my database, and this table called T is not for Texas. It is for table, and this T table has a clustered column store index on it. And if we do a stupid looking left join to that table, I messed that all up. Apologize. It's the first mistake I've made all day. We do this stupid join to our T table, something interesting will happen. Get you out of here. But this finishes now in about 2.2 seconds, because we have a bunch of stuff that's going to happen in batch mode now. We see this window aggregate operator. Fantastic. Fantastic. We're going to have a sort that happens. Second mistake I've made today. This sort that happens in batch mode. We have this window aggregate that happens in batch mode. And because the sort is a child operator of a window aggregate, all this can parallelize rather nicely. A rather nice parallelization. But batch mode sorts when they're not the child operator of a window aggregate. All the rows end up on one thread, which can sometimes be worse. I mean, they're still getting the batch mode efficiencies of this sort, but that whole one thread thing is a little wonky. But anyway, that's another way you could potentially fix the query, is just by getting a row number and doing some batch moding, which is perfectly acceptable. But let's make sure we clean up after ourselves. So thank you for watching. I hope you enjoyed this video. I hope you enjoy the remainder of whatever day this is. And, well, maybe in the future I'll drink some more Monte Carlos and get talkative and record some more videos. I do miss you. Where have you been? Huh. Around, I guess. Cheers. Thank you. I was going to say something profound. Forget what it is now, though. That always happens to me. It's right on the tip of my tongue. Well, anyway.